In question number 1, the line y is equal to mx plus c cuts the ellipse in two real points. So therefore, convert either coordinate in x or coordinate in y. Substitute y is equal to this value. It becomes x square by a square, mx plus c whole square by b square is equal to 1. If I cross multiply, this becomes b square into x square plus a square into total quantity. You are going to get. Try to convert in a standard quadratic equation, that is b square plus a square m square x square 2mc a square into x plus a square into c square minus b square. This is in the form of ax square plus bx plus c. So therefore, since the line cuts the ellipse in 2 points, therefore it has real and distinct roots. Therefore delta greater than 0, then you get the required condition. Now we are given with the ellipse x square by 5, y square by 3 is equal to 1. S1 and S2 are the foci of an ellipse. F1 and F2 are the foot of the perpendicular from the foci to the tangent. Let the tangent be in the slope form is y is equal to mx plus square root of a square m square plus b square. This is the perpendicular distance. This is also perpendicular distance. Find the perpendicular distance formula by using modulus of ax1 plus by1 plus c by square root of a square plus b square 2 times, one from a comma 0, other from minus a comma 0 to the same tangent. If you simplify, you are going to get b square when a greater than b. When a less than b, the answer is a square. What's the b square? The b square is 3. And if it is what a less than b, the answer is 5. That's answer. In question number 2, we have to find out the point of intersection of two tangents drawn to the ellipse x square by 3 plus y square by 2 at the ends of the lattice rectum. It's a conceptual problem. It may be a parabola, it may be an ellipse, it may be a hyperbola. The tangents drawn at the ends of the lattice rectum always intersect on a directrix. That too, it's a foot of the directrix. So therefore, aptly speaking, for a parabola it becomes minus a comma 0. For ellipse it becomes a by e comma 0. So it may be minus a by e comma 0. If you take this ends of the lattice rectum negative side, you get minus a by e comma 0. If you go in a positive side, you get a by e comma 0. Yes. Find out the vertex, find out E. E is nothing but square root of a square minus b square by a square. Find out E, that's it. Therefore, Z is equal to a by e comma 0 is the point of intersection. Substitute the value of a and as well as E, you get required answer. In question number 4, the point we have to find out on the ellipse, at that point, the tangent makes equal angles with the axis. Okay, let the point be a cos theta comma b sin theta. A is equal to 5, b is equal to 12. So therefore 5 cos theta comma 12 sin theta be a point on the ellipse at which the tangent makes equal angles. So let it be this line equation, we wrote it in the form of y is equal to mx plus c, m is equal to plus r minus 1, equal angles. So therefore minus 12 by 5 into cos theta by sin theta is equal to plus r minus 1. I got it, tan theta is equal to 12 by 5. Yes, from this triangle, I can find out cos theta and sin theta, therefore the required point. In the question number 5, we have to find out the equation of tangent at one end of the lattice rectum. So therefore, take this as L of a comma b square by a as x1 y1. We have to find the equation of tangent at x1 comma y1 to the ellipse s is equal to 0 is s1 is equal to 0. This becomes x1 by a square plus y by 1 by b square minus 1 is equal to 0. Yes, after simplification, wherever x1, y1 is there, we are liable to take as a comma b square by a. So therefore, this becomes x by a into a e plus y by a minus 1. This is the required answer. Yes, in question number 6, the angle between the pair of tangents drawn from the point 1, 2 to the ellipse 3x square plus 2y square is equal to 5. Yes, let p of x1 comma y1 is equal to 1 comma 2. Y is equal to mx plus square root of a square m square plus b square represents the tangents which are passing through the point p of x1 comma y1 is given by 1 comma 2. Yes, I have taken, yes, substitute x and y is equal to x1 by 1. Squaring on both sides, we got it. This is the quadratic equation in M. Its roots are m1 and m2, sum of the roots and the product of the roots. Let theta be an angle between the two tangents. Therefore, tan theta is equal to m1 minus m2 by m1 plus m1 into m2. Yes, you know m1 plus m2. You can m1 and m2. You can find out m1 minus m2. Yes, after finding that, we get the angle between the tangents of an ellipse is tan inverse of, yes, so 12 by root 5 it is. The line AB having x1 comma y1 as a midpoint by using intercept form, if it x by a plus y by b is equal to 1, if it is having x1 comma y1 as a midpoint, yes, if I take this as a comma 0, if I take this as 0 comma b, we have proved already. Yes, we got it. A is equal to 2x1 and b is equal to 2y1. With that concept, we are able to write its equation as x by x1 plus y by y1 is equal to 2. Later, this line is a tangent to the ellipse. Then the condition is s square L square plus b square m square is equal to n square, or c square is equal to a square m square plus b square. Apply this condition, we get required result. In question number 8, we have to find out the ratio of the areas of SPS dash upon area of a triangle APA dash. S and S dash are the foci, A and A dash are the ends of the what? Major axis. Meanwhile, PB, any point on the ellipse, any point means without loss of generality, we can take it as B of 0 comma B. So therefore, half into base into height, therefore half into SS dash into B, half into AA dash into B. We know that SS dash is equal to 2A and B is what? This length from this center. So therefore, now this is also 2AB. All terms get cancelled. We are left with E by 1. That's the required answer. In question number 9, find the equation of tangent at 4 comma minus 1 to this ellipse is S1 is equal to 0. Is given by x1 by a square, y by 1 by b square minus 1. This is L1. In the same fashion, you find out the equation of tangent at 2 comma minus 3 to this ellipse x square by 25 by 4, y square by 25 is equal to 1. He has given another ellipse, right? Now, equation of tangent is given by S dash is equal, S1 dash is equal to 0. It is given by x1 by a square, y by 1 by b square minus 1, called as 2. Now apply the distance between L1 and L2. That gives the required answer. Question number 10. The tangents are drawn through the point 4 comma root 3 to the ellipse x square by 16 plus y square by 9. The points at which these tangents touch the ellipse is, the very first method is, right? Now, where the tangents are touching the ellipse means this option, what are the alternatives are there, they must satisfy the tangent as well as the ellipse, because this point lies on the tangent as well as what? Ellipse. Take the options, keep on verifying the what? Ellipse. That gives the required answer. That is first method. So we want second method, sir. Yes, I go in a what? Different way. Take these tangents as y is equal to mx plus square root of a square m square plus b square, right? Take that as tangents in a slope form passing through this point. That gives the values of m. Later you can substitute there. That gives the equation of tangents. question number 11, the number of values of c such that the line y is equal to 4x plus c touches the ellipse. Means whenever the line y is equal to 4x plus c touches this ellipse, we know the necessary condition c square is equal to a square m square plus b square. So therefore substitute the relevant values. I got it plus or minus root 17. So the number of values of c are 2. In question number 12, we have to find out a tangent to ellipse is equally inclined with the chord axis, then the perpendicular distance from the center to the ellipse is. Yes, for this ellipse, the tangents are in the form of y is equal to mx plus or minus square root of a square m square plus b square, right? A square is 4, b square is 3, right? M is given to be plus or minus 1. Why? They are equally inclined with the coordinate axis. They make 45 and 135. Therefore, slopes are plus or minus 1. Substitute in the tangents. Yes, I got it. 2 tangents. Apply the perpendicular distance from the center to this line. That gives the what's square root of 7 by 2. In question number 13, we have to find out the tangents are drawn to the ellipse at the ends of the latus rectum. The area of the quadrilateral so formed, yes. This is L of a comma b square by a. Similarly, a comma minus b square by a. Here you get what? Minus a comma b square by a. Here minus a comma minus b square by a. Now instead of going for tangent, just I find out a tangent at this point to this ellipse. Let this ellipse be in the form of x square by a square, y square by b square minus 1 is equal to 0 is given by s1 is equal to 0. What is your x1, y1? A comma b square by a. Substitute. This tangent becomes s1 is equal to 0 as ax plus y minus a is equal to 0. Now total area is equal to the 4 times the area of this triangle. What's a triangle? OPQ. So therefore required area is equal to area of the triangle formed by ax plus by plus c with the what coordinate axis is nothing but c square by 2 into ab. That gives the required answer. 14th, the equation of normal to the ellipse x square plus 4y square is equal to 25 at the point whose ordinate is 2. Right. I take the point as x comma 2. This lies on this ellipse, right? So x is equal to x and y is equal to 2. This becomes x square plus 16 is equal to 25. Later we get x is equal to plus or minus 3. Verify the options. You put a what? This as 3 comma 2. Find the equation of normal. That gives the required answer. Or else substitute what 3 comma 2 in the given alternatives. That gives the required answer. When y is equal to mx plus c is a tangent to both ellipse and circle. For ellipse, c square is equal to a square m square plus b square. For circle, c square is equal to r square into 1 plus m square. Eliminate c square from both the equations. I got the required result.